Chapter 3, Hardware. What are the learning objectives? By the end of this chapter, you should be able to show understanding of the need for input, output, primary memory, and secondary memory, including removable storage. The inputs are there, the processing will take place, and then the storage, and then the output. Storage is primary memory, that is RAM and ROM, and the secondary memory, hard disk, SSD, all the removable things, CD, diskette, floppy disk, pen drives, all those things. So understanding of embedded systems, that is like phones, washing machines, many household items which have microprocessors doing the processing and the program is embedded in it. Describe the principal operations of hardware devices, how the hardware devices operate. Show understanding of the use of buffers. Buffer is a storage area, temporary storage area. Explain the differences between random access memory, RAM, and read-only memory, ROM. Explain the differences between static RAM and dynamic RAM. Difference between programmable ROM, that is PROM, erasable programmable ROM, EPROM, and electrically erasable programmable ROM, that means EEPROM. So the very first thing is overview of computer system hardware functionality. The system has to support the processing of data. Who does it? The CPU. Not a human, though I said who, but it is a CPU that does the processing, and that will be done in chapter 5. The storage of data. Where do you store the data? And the input and output of data. Input, very important, and the output is the useful information. Let's take that. Processing is not covered in this chapter. One is the storage of data. Memory. You have the memory, which is primary memory. Processor can access directly. There are two kinds of memory. The other one is file store, or secondary, which is for long term. They are not accessible by the processor directly. That's the difference. Memory, which is RAM and ROM, they can be accessed by the processor directly. So here is a chart. Trends in the factors affecting the choice of memory components. So the component here on this column, category, and the access time, capacity, size, cost, various indicators here. So let's take the first one, register. What's the category? Processor component. Register is a very tiny, like 1 byte, 2 bytes, or 2 bytes, or 4 bytes, like that. Very tiny. Register means area. In the CPU, in the processor, you have a small data areas. They are called register. And that access time is like the fastest, the fastest or the highest speed or the shortest access time. Shortest access time is register. Then the cache and the capacity also highest. Capacity also very small here. Register is very small, going up with these other items. Size also small, increasing this way. Size also small, only the cost is high. Only the cost is high, access time is low, not slow, access time is low. So very short, quick access time. Capacity is also low. I told you very small, tiny areas. Size is also very small, same thing. Then the cache memory and main memory. Cache memory and main memory. They are in the primary storage. Cache is also fast. It is also fast, but not as fast as registers. And they are in all these things more than uh, the register. Only the register, only the this one is lower. That means cache and memory is less costly than the register. Then comes the hard disk and the auxiliary storage. Hard disk, auxiliary storage, the other things like pen drives and CDs, all those things, secondary. Their access time highest, that is slowest. Access time is more means the speed is very slow. Then the capacity very high. Capacity is very high. This time is very big, very long. Size is also big. Size is very big. And the cost is less. And the cost is the other way around. Lowest priced one. Trends in the factors affecting the choice of memory components. Cache. What is cache? Cache is a built-in part of the CPU chip. It keeps some parts of uh, memory or what is being used frequently used parts of programs and all that, they are stored here so that the program can work very fast. Then the media, storage media or devices. Hard disk or solid state drive that is inaccessible to user. Hard disk is fixed inside. Solid state drive is also in place of hard disk. The newer version is SSD, solid state drive. So they are fixed inside and the user cannot touch it or access it. Floppy disk, optical disk, or magnetic tape cartridge. That is, those things are inserted into a drive for use. So that is different to hard disk and solid. Then also you get external hard drive, memory stick, or a memory card, peripheral, which can be connected to the system. Peripherals. Then you get cloud storage. You have heard of cloud storage, we have done. Remote from the system, access via network. Google worksheet that I have, Google Drive is there. So this kind of thing is done in the cloud. The storage is there. We can access from anywhere. I don't have to carry my computer wherever I go because those files, what I have stored in the cloud or Google Drive, there are many other providers like that. I can go anywhere and access it if there's internet connection. From any device, I can access it. Then we come to data output. Third part, data output. You have the screen display. Yeah? Screen display, you can see the output. Hard copy, that is printed output. Printers do the hard copy output. Virtual headset display. Virtual headset display where it looks and sounds very real. Then the speaker, right into data storage devices. And is also an output. Okay, all these are, we're talking about output, virtual headset display also. Output coming for you to see. The speaker will give out the sound. Right into data storage devices. If you are saving a file onto a hard disk, what is processed and all the data that is processed, put into a file and save on the hard disk, that is also output. Then the transmission on a network link. You are sending, you collect a lot of data and then send it to another location or another institute or a company or office or branch or something to send it. So that is transmission on a network link. That is also output because all these things going out from the CPU. Let's look at it from the system, from the memory. Screen also from the going out. Hard copy going out to a printer. Virtual headset display, the processor will give you the details on a headset. Speaker also, sound will come out from the speaker from the computer. Right into data storage devices, the hard disk. From the memory, the CPU will transfer that into the sending from the CPU to the CPU or the memory, RAM, to the secondary storage devices. So that is going out. That's why output. Transmission on a network link also output because we are going from your computer to another place. Now let's look at the data input. What are the devices? Keyboard or keyboard entry, touch screen, game control, scanner, microphone, reading from storage device, transmission on a network link. See the last three items, microphone, here the speaker. Reading from storage device right into data storage. Transmission on a network link, same thing. Huh? We are sending out. Here we are receiving input. Embedded systems, what are they? They contain a processor, like the computer having a processor. These embedded systems also processor, memory, and I/O capability. That is input-output capability. If these are constructed on one chip, then it's called a microcontroller. The system can provide a full user interface. Example, in a mobile phone. The mobile phone, full interface. That's also an embedded system. What are the things? Processor. Processor is there. Then the memory is there in a phone and I/O capability, input and output possible. No? They are special purpose, possibly performing only a single function. Take, for example, a washing machine. You can't program it to do something else, wash dishes or something. It's one program and it's embedded in it. Single function. So that's why it's called special purpose. General purpose is you can do anything, any other programs also possible one. So earlier, it was a disadvantage. Programming was difficult. What is the disadvantage? Programming was difficult. Why? Because the memory space available to store a program was limited. All chip is limited. Now let's look at the phone, the size of the phone and the size of your computer, which can hold more anything, memory or whatever, right? The computer can hold more. No? Phone is less. So the programming also was difficult because the memory space was not enough. There was the disadvantage that if errors were found following installation, then new chips had to be manufactured and used to replace the faulty ones. You know that there was a fault, then you had to replace it. You had to manufacture a new one and send it to the user to replace. Nowadays, it's not there. Then new chips had to be manufactured and used to replace the faulty one. In modern systems, less such problems. Those are not very common. But there are advantages of this new technology, IoT. What is that? Internet of Things. Everything connected to the internet. So installed with network connection, Useful, why? Providing information and updates to the owner is very easy. Not like those days, sending a CD or something. But here, just connect it to the internet and the updates are available. But then there's a new problem. What is that? Security concern. Who is going to protect your devices from the internet threats? Memory components. The key terms are RAM and ROM. RAM is volatile memory that can be read from or written to any number of times. Read-only memory, non-volatile. It means temporary, only till the power is present. The non-volatile memory that cannot be written to, you can't write anything into the ROM, but can read from. You can read what is there. Instructions can be read from any number of times. Can read from any number. Then the RAM, we'll take the RAM separately and see. Can read from RAM. Write to RAM, yes. Volatile, that means it's temporary. When you switch off the computer, everything is erased. There are two types. One is DRAM, the other one is SRAM. DRAM is dynamic. SRAM is static. So constructed from capacitors. DRAM is constructed from capacitors. What are capacitors? Electronic components that leak electricity and therefore need regularly recharging every few milliseconds. So these capacitors, if you can learn a little bit of electronics, find the properties of it, you charge it and then it leaks. It goes down after some time. So because of that, you need regular recharging. So every few milliseconds, you have to send a charge again, recharge, refresh. Cheaper to make. It's cheaper to make and has a higher density for data storage. Now compare this to the hard disk, which is cheap but higher capacity. Registers, very expensive, less capacity, very tiny. Same way here, when when it is cheap, density for data storage, high density. So it has large, high capacity, but cheap. Used to make main memory. So to make main memory, you get this DRAM. Then SRAM, constructed from flip-flops. You will learn about flip-flop. These are circuits. We will learn in chapter 19. Circuits which can keep them, the current circulating inside the circuit that continue to store data indefinitely while the computer system is switched on. So that's capable of keeping it. So no need to refresh like this every few milliseconds. You don't have to refresh because there is no leak. It retains the power. Short access time. Right? This one doesn't say the time, about time. So that means shorter means what? Shorter than DRAM. You have to check these, you have to detect these subtle things, very tiny things that are there. You must learn on your own also. You can learn. This means shorter than DRAM, but it's not mentioned there. On our own we learn. Then used to make cache memory. So we learned about cache a little while ago. That is made out of this SRAM. Used to make RAM in embedded system. Phones, washing machine, microwave ovens, many devices. Then the RAM in that, RAM is embedded into a chip, microprocessor and all these things. So then for that you use SRAM, static RAM. Tip. The word volatile has several meanings. Try to remember that volatile memory no longer stores data when the system is switched off. Then we come to ROM. We can only read from ROM. We can't write to ROM. And non-volatile, which is permanent. Those the bootstrap program. What is the bootstrap program? When you start the computer and empty, RAM is empty, and the CPU is not capable of doing anything without instructions which are in the RAM. So when you switch on the computer, the RAM is empty and the CPU cannot do anything without any instructions in the RAM. So what are the instructions it needs initially? The operating system instructions, no? OS, before doing any other program, before example, loading MS Word, Excel or anything, the OS should come to memory first. Without that, CPU is helpless. So how do you get it? If the CPU is helpless, how can you get where is it now? It's on the hard disk. On the hard disk, it's stored. And where are the instructions to take it? It is in the ROM. This is what we call bootstrap program. Bootstrap program, that is in the ROM. It's non-volatile, so it won't get erased. You can't write into it. No one can change it. And the manufacturer has put this program to start the computer or boot the computer. Starting the computer and booting the computer, I have told you. When you switch on the computer, the power will come. But if the operating system is not loaded successfully and you can't do any work, then it's not booted yet. Just started. Booting means loading the operating system successfully. Then you are ready to do any work. The CPU is ready to do any work. You can do. So this ROM is used in many embedded systems. There are 4 different types of ROM. What are they? In the simplest type of ROM, the programs or data are installed as part of the manufacturing process. So, if different contents are needed, the chip must be replaced. So to need some change to the contents, then you have to remove the chip or the IC and replace it with a new one. That is one type. Then another one is programmable ROM, PROM. The manufacturer of the chip supplies chips to a system builder. System builder is the computer manufacturer and the ROM manufacturer is there. He gives this system builder. The system builder installs the program or data into the chips. Into the chip, the program is embedded. This allows the system builder to test some samples of programmed chip before committing the whole batch to be programmed. So it's like proofreading. When you give an order to a printer, maybe some invitation or some notice. Before printing, he gives you a small sample to see. It's called proofreading. You check whether everything is okay. Similar thing happens here. When that is finalized, then it can be manufactured mass scale. As with the simplest type of ROM, the program or data once installed cannot be changed. So that we already know that it's that it cannot be changed. It cannot be changed, right? That's the second type. Now the third one is a more flexible type of ROM is erasable PROM or EPROM, EPROM. The installed data or program can be erased. How? Using ultraviolet light. A new data or a new program can be installed. However, this reprogramming usually requires the chip to be removed from circuit. You have to remove the chip or the IC from the motherboard, and then only you can reprogram it. That is PROM, EPROM, erasable programmable ROM. The fourth one is the most flexible type of ROM, which is electrically erasable ROM. Two is electrically erasable, that is programmable ROM. As the name suggests, this works in a similar way to EPROM, except an electrical signal can be used to remove existing data. So you don't have to remove the chip, unlike the earlier one. Electrical signal, while it is there on the board or the circuit, you can. This has a major advantage that the chip can remain in the circuit while the contents are changed. However, the chip is still used as read-only. So still, it will be used as read-only. Then we go into buffers. As I told you before, temporary storage area. Whenever data has to be transferred from one part of a computer system to another, there are many instances of transferring data from this place to that place, like that. A problem occurs if the data can be sent more quickly than it can be received. So you are sending at X, speed of X, then receiving speed of Y. Y is slower than X, then what happens? You are like forcing data which cannot be received by the other part. Then that is a problem. The solution to the problem is to use a buffer, like a place, temporary place, without rushing it everything to there. You just keep it here. Data enters a buffer before being transmitted to its destination. So first it goes into a buffer, then only it will go into the destination. The buffer functions as a queue. So the data emerges in the order that it has entered the buffer. Right? So you keep it in a place, and then like you may have seen certain places when a lot of people are coming, you send only about 5. When the corona started also, like supermarkets, they allowed only 20 inside the thing or whatever, depending on the size of the capacity. So you just keep them. So typically the buffer functions as a queue, so the data emerges in the order that it has entered the buffer. So first come, first serve. The first one who came waits the front of the queue, and then likewise. Typically, the buffer is created in the computer memory. So it's kept in the computer memory, like a waiting room in the real world. The real world also, you get waiting rooms places. No? If you are not accepted, you are not ready, you have to wait. You have to wait until the others go or something like that. That's a waiting room there, which is similar to the buffer in the computer memory. What you have to remember is it's a temporary storage area and it's in memory, RAM. Now we come to secondary primary ones. So you have magnetic media, that is tape, hard disk, floppy diskette, zip, and gas. Those are the things. And then you have DVD and Blu-ray, and the solid state media. So these are the 3 types. So first let's All these things, magnetic media and tape, that means magnetic tape, magnetic hard disk, magnetic flop disks, all these are magnetic. Zip, jazz, these are not popular. They were there only for a very short time. Zip disk and jazz disk. A schematic diagram of a hard disk is shown in figure 3.02. Points to note about the physical construction are, see that this is the diagram. There is more than one platter. So that's, now this one hard disk, but there are three platters here, or three disks, three plates like this, three circles. There is more than one platter. The term is platter, this one. Each platter has a read-write head for each side. See, these are the read-write head. Read-write head is the actuator arm. This is the actuator. Read-write head. So this has on either side. This is a platter. This, you can see this arrow is coming onto the top side, and there's one on the bottom underneath this also. Both working at the same time. So the platters spin in unison all together and at the same speed. So these all must spin at the same speed in unison. Unison like one. In like spin like one. Like if they are fixed together, how do they spin? The same speed. No? So like that, it should spin at the same side. Otherwise, what happens? The data will be, when you read again, if these speeds change, like playing a song in the wrong speed, you don't get the correct voice or the correct music, no? Then the read-write heads are attached to actuator arms. So this is the actuator arms. It's like a robotic arm, which are controlled by the computer, which allow the heads to move over the surfaces of the platters. So this will move. How do these heads move? Because this is there, it can turn only this way. So either this point, if this is the point which the head is there, this is like an arm here, another extension of this arm. But if the head is just here, just one point, can read one track at a time like this. These are the tracks. Here's the tracks. This is one track, the red one, another track, another one. Right? So the data is there. So this small point, if it is here, then it can move like this, either there or that's all, either there or back here. You can go to the edge of that. These are turning. These are turning. Now this is at the inside, the inner place, the head. If you want, if the data is somewhere here, then it has to move there and wait. Then if it is turning, it will read. Or if it is go to the outer edge, then you go there. Then come back. Maybe the file is in two different places or two files. First finish one there, then to take another one. Like that. The motion of each read-write head is synchronized with the motion of the other heads. So these heads all do like synchronize, same way. If this moves that way, all move that. If this moves to the middle, the center of this track, then these others also do the same thing. That is, the motion of each read-write head is synchronized all together with the motion of the other heads. Then cushion of air ensure that a head does not touch a platter surface. Now this is airtight. This is sealed. All this is put together. You may have seen hard disk. You see, it's enclosed, it's sealed. You can't see these platters and read edits and all that unless you remove it. You open. So it's covered and sealed. It's airtight. This turns at about 7,000 revolutions per minute, RPM. So when that rotates so fast and with the air enclosed in a sealed container, this tends to go up a little. The head, the read-write head, moves a little bit up above this. It's not touching the surface, just tiny bit up. Where the air is traveling through this, it will lift like a plane. The plane goes fast on the ground due to the air, the drag, the pressure of the air. Then it will go up. Same way, this will also raise a little bit. So it's not touching. A cushion of air ensures that a head does not touch a platter surface. If it touches, what happens? By some error, maybe the power problem, power goes off without shutting down or something like that. And then what happens? This will, if this touches at that high speed, and this is metal, this is metal, it will scrape this and damage the data. If it so you won't be able to use those places, the files that are stored in the damaged area. Supposing if it damages the area where the boot, we were talking about the boot program, can you remember? There's a thing called boot sector. These are sectors, right? These sectors, you have a one particular thing called boot sector. From there only, the operating system is loaded. So if you can't, if this is affected, if the head falls onto this place and it affects the boot sector, then you have to throw this hard disk because you can't do anything. Even to correct it, to repair it or anything, you can't do anything because the computer doesn't start with that. So you have to throw away. That is why it doesn't touch. Make sure that it doesn't touch. A schematic diagram of the components of a hard disk drive with this. So let's go through the diagram again. Concentric tracks. Concentric tracks. That means these tracks all have one center. One center. And outside, concentric is one center and then not a spiral also, separate tracks without touching each other. Each track consists of a sequence of bits. These are formatted into sectors where each sector contains a defined number of bytes. The sector becomes the smallest unit of storage. So this sector is the smallest unit of storage. The collection of tracks is referred to as a cylinder. So when you when you take this, and it's called a cylinder. See? Cylinder. Now, if you draw lines like this, not physical, there's nothing like that. But logically, if you draw lines like that, it will be a cylinder. Use of the sectors become fragmented. So these sectors where they are saved, the files can get fragmented, means one piece here, another piece there, another one there, one part of the file is there. So all defragmented, and which means this read-write head has to go up and down, up and down, up and down. It becomes slow. So in order to make it fast, there is a program called defragment. Defragment. Like get all the fragments, the pieces, and put together. Then again, just one revolution is enough to read that whole file. Then direct access read-write device. So now head is there, the arm is there, the spindle. Spindle is this, like an axle. Around that only this revolves. That cylinder. Okay. So all cloud. Block. Block is like block of data. Part of one section like this. In concentric track, we read that. Then optical media. Optical media is CD, DVD, Blu-ray. That is because you're using a laser beam to burn and read. So optical laser is light. Laser is also light. Optical is connected to light. Developed from existing technology, not associated with computing system. So the CDs didn't come for computers. Earlier they were being used. That was adapted to computers later on. CDRW, that is read and write. Replacement for floppy disk. So floppy disks were replaced when this came, CDRW came. Till then, floppy disks were also there. Earlier CDR, that is read only. Then what happened? CD gave into DVD and now Blu-ray, highest capacity now. Here is a diagram, a schematic drawing of an optical disk drive. Optical disk drive is technical details there. You don't have to worry if you can't remember these things. Just if you just read it and then there's a tracking system, then the mirrors are there like that. If you have a rough idea, that will be enough. The optical disc has one spiral track running from the inner extreme of the surface to the outer edge. So there is a difference from what we saw. This is the concentric one center, and but the CDs and DVDs, you have the spiral. During operation, the disc spins, all right, that we know. Simultaneously, the laser moves across, ensuring that it is continuously focused on the spiral track. So in the hard disk, the read-write head moves. Same way here, the laser moves across, ensuring that it is continuously focused on the spiral track. The track on the surface of the disk has what are referred to as pits and lands. Pits and lands. So here also a binary thing, two marks. If pits is 1, then lands is 0. So computer needs only 0 and 1. If that can be provided, okay, fine. The laser beam is reflected from the surface of the disk. So the laser beam is reflected. The difference between the reflection from a pit compared to that from a land can be detected. That is how, whether it's 0 or 1, it's detected after the reflection. This difference in the intensity of the light the detector receives can be interpreted as either a 1 or a 0 to allow a binary code to be read from the disk. So when you burn, called burning a CD, the laser will make pits like holes, and some places won't make anything. It will just remain. That will be a 0, or the other one is 1, or this one is 1, or whatever. Anyway, the two different things are, one is a 0, the other one is a 1. So when the reflection comes, there's a difference in the light. So that is detected and identified as either 0 or 1. Then comes solid state media. Pen drives, SD cards, USB flash drives, no moving parts. The basis for this is flash memory. It's solid state media, flash technology, flash memory, which is a semiconductor technology with no moving parts. Big difference from the magnetic and laser or optical. No moving parts here. The other two have moving parts. The circuits consist of arrays of transistors acting as memory cells. The most frequently used technology is called NAND. In the logic gates, you do NAND gates, AND gates, NOR gates, circuits, logic circuit gates. Because the basic circuitry resembles that of a NAND logic gate, see chapter 4 for details. So the next chapter will be doing logic gates with the memory cells connected in series. Then blocks of memory cells can have their contents erased all at once in a flash. So that's another reason why this is called flash memory. Furthermore, before data can be written to a block of cells in the memory, the data in the block first has to be erased. For writing, you have to erase it. A block consists of several pages of memory. And memory is broken down into sections, and they are called pages of memory. A block consists of several pages of memory. When data is read, single page of data can be read in one operation. That's a rate. In one operation, one page can be taken out. So now we have storage and the input and output of data. We have done the storage, and now we are just coming into the output devices provided for this another section, which we will see in the next video. So for today, that's it. Bye. Hope you will learn something from this and do the assignments. Good luck. Bye.